Hello everyone and welcome to On the Spot STEM. Today we'll be solving the LeetCode day number 4 move zeros from the 30-day challenge on LeetCode. The problem states given an array of nums, write a function to move all the zeros to the end while maintaining the relative order of the non-zero elements. Now, this problem does make us think that we can do a brute force n squared algorithm and just try to keep moving the zeros to the front every time we see a zero. But we see that we must do this in place without making a copy of the array, and our goal is to minimize the total number of operations. So we need some clever thinking in order to reduce this problem down. So the strategy that we have to come up with is similar to the caterpillar game, if you have ever played that, where we think of it like a train of zeros running and trying to collect more zeros, and they always send the back zero to the front. Now that sounds very confusing at first, so let's break it down with the following test case. 0, 1, 0, 1, 0, 1. So what does this mean? Well, the backmost zero, sees that there's a 1 here, so he and they swap. And then what happens after the swap? Well, then the array becomes 1, 0, 0, 1, 0, 1. And just like before, we treat the train of zeros, or these two zeros, and we basically take the end and move it to the front like a caterpillar. So we take the end, pop it to the front, and we take the 1 and we move it back there. So then what we get is the array 1, 1, 0, 0, 0, 1. Now we have this contiguous block of zeros, and the end is this last zero over here. So he gets moved to the front, while the 1 gets popped to the back. And from here, we get an answer of 1, 1, 1, 0, 0, 0. So it seems like there's two things that we need to track. We need to track where the train of zeros end and where the train of zeros begin, because those are the two elements that are swapping. This inspires us to take a two-pointers approach. So let's look at the actual code that we use to get this done. So we store a left pointer and a right pointer. Those mark the beginning and the end of the train of zeros. And our right pointer is bounded by the length of the array. And anytime the right pointer encounters something that's a 0, so it gets over here, it increases because it needs to move past to the beginning of the train, which is whatever is not a 0. So once it does encounter something that's not a 0, it switches whatever it saw with whatever is the beginning of the train, and that's just the end of the train sending it over to the beginning. And then the end of the train also has to increase to accommodate for that switch. So let's submit this code and actually see how it performs. So we see that our code was accepted, and when we look at the submission details, we see that it passed and it beat 100% of the Java submissions. So if you enjoyed this video, make sure to like, subscribe, and share with anyone who's interested. And be on the lookout for any other videos that we'll be posting soon about LeetCode.